அனைவருக்கும் வணக்கம். யாவரும் கேலி திறனுலர் சங்கம் பெருமையுடன் நடத்தும் நிற்க அதற்கு தக மாணவர்களே ஆசிரியர்களாய் வாரம் 10 நீங்கள் அறிந்ததை மற்றவர்க்கும் கற்பித்தால் நீங்களும் ஆசானே. வாரந்தோறும் சனிக்கிழமை மாலை 6 மணிக்கு YK டேலண்ட்ஸ் நேரலையில் காண தவறாதீர்கள். இன்று நம்மளோட இணைந்திருக்கிறது யாருன்னு பாத்தீங்கன்னா சௌந்தர்யா. நமக்கு என்ன சொல்லி தராங்க அப்படின்னு பார்த்தா அஸ்ட்ரானமி அண்ட் அஸ்ட்ரானமிக்கல் ஆப்ஜெக்ட்ஸ். ஆல் தி பெஸ்ட்மா. யாவரும் கேலி திறனுலர் சங்கத்தின் சார்பாக வாழ்த்துக்கள்.
Thank you, ma'am.
Thank you.
A pleasant evening to everybody. I am Soundarya, currently doing my undergraduation in physics from Marudar Kesari Jain College for Women. The topic I have chosen for today's webinar is on astronomy and astronomical objects. And this is all about space and space object. In this module, we are going to see about astronomy and about observational astronomy, theoretical astronomy, and some specific subfields of astronomy, and many astronomical objects like stars, nebula, white dwarf, neutron stars, etc. Have you ever wondered of seeing the night sky? The night sky is always beautiful with twinkling stars and moonlight. The space is full of mysteries and many unknown space objects. Space is for everyone. There are many mysteries to be uncovered and unfold. Night sky is always astonishing. Many have get some kind of questions like, who created this universe? Why it is created? Where do we come from? Where we are going? These are some of the questions associated with astronomy. We seek answers to these questions from ancient time to the present day. This is what the astronomy deals with. Astronomy is the study of science that has its main purpose in the determination of position, dimension, and movement of the celestial bodies. But where the universe began? We know we humans live in a place called India. Our India is a part of this gigantic earth. Our earth is a part of the solar system. Our solar system is a part of a spiral galaxy called Milky Way galaxy. Our galaxy is in this vast observable universe. You know, every object in the universe is not stationary. As our earth revolves around the sun revolves in the Milky Way galaxy. Our Milky Way galaxy revolves in this giant universe. So every time the position of everything is changing, nothing is stationary, everything is dynamic. But how did this great universe begin? Universe is everything, from the tiniest particle to the largest galaxies, to the very existence of the space, time, and life. But how did this all begin? Origin of universe is the origin of everything. Multiple scientific theories plus creation myth from all around the world have tried to explain this mysterious genesis. However, the most widely accepted explanation is the Big Bang theory. Many have these questions like whether the God created the universe and everything, but still now we don't know who created the universe. But this is the widely accepted theory called Big Bang theory. The Big Bang theory states that the universe began as a hot and infinitesimally dense point of only few millimeters wide. It is compared in a similar way to a supercharged black hole. This happened about 13.7 billion years ago. This tiny singularity violently exploded. From these explosion, all the matter, energy, space, time were created. You know, before Big Bang, nothing has ever existed. Even nothing has existed. After the explosion, only everything, space, time were created. What happened next is the two major stages of the universe evolution. First is the radiation era. Second is the matter era. The name radiation era came by the more concentration of radiations after the Big Bang. Next, the matter era came, where the result of these radiations result in the production of atoms. Here is a brief about Big Bang theory. When the explosion happened, that the time started at 10 power minus 43 second. The cosmos undergone a super fast inflation, that is expanded in a very big speed than the speed of a light year. Light year is the distance covered by the light in 1 year. So compare that 3 into 10 power 8 kilometer per second is the speed of light. Even the greater than that, the explosion was there. After 10 power 32 second, our universe is considered to be like a hot soup with full of cracked particles and other particles. These were the major ingredients for formation of the current universe now. At 10 power minus 6 seconds, the temperature of the universe is 10 power 13 degrees Celsius. From 10 power 27 to 10 power 13 degrees centigrade, the temperature cooled. This is where the cracked particles, called the primary particles, combined to form protons and neutrons. After 3 minutes, the temperature cooled to 10 power 8 degrees centigrade. But this temperature was also too high for the formation of atoms. That time, the universe was considered to be a super hot fog, like now we have the winter fog, like that. It's considered to be a fog with super hot. The fog prevented the light shining. This is the radiation era. Up to this, the radiation era completes. That is 3 minutes after the Big Bang. Then, from 3 minutes to 300,000 years later, the temperature cooled to 10,000 degrees centigrade. This is where the electrons combined with protons and neutrons to form atoms, merely helium and hydrogen. Helium is the first formed atom in the universe. Second is the hydrogen. Later, these helium and hydrogen combined to form other elements like lithium, beryllium, boron, copper, nitrogen, oxygen, and many other elements of our recent periodic table. Then 1 million years later, the temperature cooled to minus 200 degrees centigrade. This is where the gravity comes into act. The gravity makes the hydrogen and the helium gases to form a giant clouds, which will become the galaxies in future. Similarly, the small clumps of gas collapse to form the first stars. After 15 billion years, the temperature cooled to minus 270 degrees centigrade. This is where the galaxies form. The galaxies are clustered together by the gravity, and where the stars start dying and they spew away the heavy metals in them into space, which eventually resulted in the formation of new stars and planets. By this, you could have come know about how this universe might be created, but this is a theory proposed. This is how maybe our universe might be created. In future, there may be in many other theories like this, which explains about the origin of the universe. This is what the astronomy deals with. Astronomy answers the questions to many unanswered questions, like who created this universe, why created this universe, what will be the present, past, and future of the universe. Astronomy is the study of everything beyond the Earth's atmosphere and their physical and chemical composition. The space objects, the naturally occurring objects, are called as the astronomical objects or celestial objects. Astronomy is called as one of the oldest natural science because before the invention of the GPS and the compass, our ancestors used stars as the guide to travel from one place to another. They determined the weather by the position of the stars. They sow and reap the crops by seeing the position of the stars. By this, we have come to know that astronomy is one of the oldest science. People start understanding the space and nature from the olden times. Some of the examples of astronomical objects include asteroids, moons, planets, etc. Professionally, astronomy is split into observation and theoretical branches. Observational astronomy is mainly focused on acquiring data through the instruments. Those data we collect through instruments are related with observational astronomy. Theoretical astronomy deals with the observational results. What the observational astronomy collect result in Earth, they convert into computer or analytical model to describe an astronomical object or phenomena. These two fields complement each other. Theoretical astronomy seeks to explain observational results, and observations are used to confirm theoretical results. Still now, no more great technology have come so that we can go into a point in space and see what's happening there. So we collect information from our Earth through some telescopes, various types of telescopes. Those informations were decoded and formed as a similar pattern in Earth to observe what the phenomenon happening in space. The information we get is in the form of radiations. The arrangement of radiations from increasing wavelength and decreasing frequency is called the electromagnetic spectrum. This spectrum includes the visible light, that is, the light which can be seen through the naked eyes. 4,000 nanometer to 7,000 nanometer is the visible light, that is where our eyes can sensible to and we can see that light. Less than the wavelength of violet is the ultraviolet. Less than the wavelength is called the X-rays, then comes the gamma rays. Greater than the wavelength of red is the infrared, and then radio waves. These are the radiations emitted by the objects in the space. Then observational astronomy has various subtypes, like radio astronomy. It deals with the radio signals from the space and collect them through many radio telescopes. And infrared astronomy, optical astronomy, this is where we use telescopes to look into the space and see the phenomenon happening there. And ultraviolet astronomy, similarly using ultraviolet. X-ray astronomy, gamma rays astronomy, and fields not based on electromagnetic spectrum, astrometry, and celestial mechanics. And then some of the specific subfields. The study of astronomy using physical phenomenon is called the astrophysics, and study of astronomy using the chemistry is called the astrochemistry, and astrobiology deals with whether the extraterrestrial life can exist. So study of those is called as the astrobiology. Similarly, there are many subfields like physical cosmology, extragalactic cosmology, galactic astronomy, stellar astronomy, solar astronomy, planetary science, etc. Our universe is very vast. We cannot even estimate how big it is, but still now we consider the observable astronomy, observable universe. We use this word, observable universe. This is up to which we are able to reach. This universe contains many millions, billions of galaxies. Each galaxy contains many millions of stars like our Earth. So there is not the only star. There are many millions, trillions of stars in this universe. Every object in the space is in a spherical shape, as rotating objects cannot attain any other shape than sphere. So stars don't come like we put stars. Stars are always in a sphere shape. As the distance matters, so we see like a point. Let's know more about star. Star is an astronomical object consisting of a luminous spheroid of plasma held together by its own gravity. Plasma is a state of matter where the ions and electrons exist together. You know, our nearest star to Earth is the Sun. Many other stars are visible to the naked eye at night, but due to the immense distance from the Earth, they appear as a fixed point of light in the sky. The star life begins in a gravitational collapse of a gaseous nebula. Nebula is a giant cloud of gas and dust. This is the place where the stars originate. Primarily made up of the hydrogen and helium and some amount of other heavy metals. No, stars is all made up of helium and hydrogen. Later, due to the thermonuclear fusion of the helium and hydrogen, other materials were created inside the star, like hydrogen, helium, next beryllium, lithium, boron, carbon, and the highest metal formed inside a star is the iron. Iron will be in the innermost part of the star. When the all fuel runs out, when all the atoms of helium and hydrogen are combined, there is no more combination, so no energy is released from the sun. So this is a place where a star dies. After a star dies, it may convert into a white dwarf or a supernova or a neutron star or a black hole. Let's see more about that in upcoming slides. Stars come in colors too. The blue color stars in the sky indicate that they are very hot. The yellow color stars indicate they are at a high temperature but less. Binary stars. Two stars that orbit the same point in the space is called as the binary stars. Star clusters, stars that originate from the same place and are gravitationally bound for some time. Now let's come to know about the origin and the death of stars. Stars origin in a region called nebula. Nebula is a giant cloud of gas and dust which contains the raw material for the formation of stars. Those gas and dust combine to form stars of helium and nitrogen. Later, the stars, after dying, they may convert into a supernova. A supernova is a powerful and luminous explosion. This transient astronomical event occurs during the last evolutionary stage of the massive star, or when a white dwarf is triggered into runaway nuclear fusion. That is, when the star loses all its energy, it converts into a supernova when the star mass is very massive. As our sun is very medium sized sun, like that 10 to 15 times greater, or the 5 to 15 times greater the mass of the sun converts into a supernova. Star is balanced between the two opposite forces. The star's gravity is in the outwards. The power released from the sun, that is the thermonuclear fusion power, is in the outward. So these outward and inward forces balance the star from collapse. But when the power released from the sun stops, the gravity overcomes. So there is where the explosion takes place. The collapse happens so quickly that it creates enormous shock waves that cause the outer part of the sun star to explode. So this is how a supernova is created. The explosion results in the spew of many heavy metals from inside to outside. This supernova may act as the birthplace of any other stars in future. Next, about white dwarfs. White dwarfs are also called as the degenerated dwarf. It is a stellar core remnant composed of mostly electron degenerator matter. When a small sized sun, like our sun star dies, it converts into a white dwarf. White dwarf doesn't release any energy like our sun. So it's in a very faint color. This white dwarf was first recognized in 1910. Currently, 8 white dwarfs are among the 100 star system near the sun. Next, neutron stars. When our mass of 10 and to 15 solar masses collapse, there is where a star is converted into a neutron star. This neutron star doesn't contain any other elements. except neutrons. No electrons, no protons. It contains only neutrons. This is called as a neutron star. Next, an interesting topic, black hole. A star may convert into a black hole. A black hole is a region in space, time, where gravity is so strong that nothing, no particle, even electromagnetic radiation such as light can escape from it. Gravity is so strong because matter is squeezed into a tiny space. This can happen when a star is dying. Because no light can get out, people can't see black holes. They are invisible. Space telescope with special tools can find these black holes. The special tools can see how stars that are very close to the black hole act differently than other stars. Now, the first black hole known is known as the Cygnus X1, identified by several researchers in 1971. Many have questions like how big these black holes may be. Black holes can be big or small. Scientists think that the smallest black holes are just the size of an atom. Black holes are very tiny, but they have the mass of the large mountain. Other kind of black hole is called as the stellar. Its mass can be 20 times more mass as our sun. The largest black holes are called supernova. These black holes have masses more than 1 million suns together. Scientists found proof that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of our Milky Way galaxy is called the Sagittarius A. It has the mass equal to 4 million suns. Could a black hole destroy Earth? Black holes do not go around in space eating stars, moons, and planets. Earth will not fall into the black hole because no black hole is close enough to the solar system for eating the Earth. Even if a black hole of same mass as the sun were taken the place of a black hole, the Earth will not fall in it because black hole would have the same gravity as the sun. Earth and other planets would orbit the black hole as they orbit the sun. But only thing we lack, we don't get sunlight. Due to that, no green energy will be produced in the earth. The plants would survive. The plants dependent organisms then would survive, but which will ultimately result in nothing in this earth. So life is not possible when the sun is replaced by sun. But don't worry, our sun will never convert into a black hole. The sun is not such a big enough star to convert into a black hole. Next, pulsars. A pulsar is a highly magnetized rotating compact star. This is also a type of star where from the both poles of the star at a regular intervals of time, electromagnetic radiations is released. These radiations can be absorbed only when a beam of emission is pointed towards Earth, similar to the way a lighthouse can be seen only when the light is pointed in the direction of the observer. These neutron stars are very dense and have short regular rotational periods. Pulsars are one of the candidates for the source of ultra-high energy cosmic waves. The period of pulsars make them very useful tool for astronomers. Next, about quasars. A quasar is an extremely luminous active galactic nucleus powered by a supermassive black hole with mass ranging from millions to tens of billions times of the mass of the sun, surrounded by a gaseous accretion disk. This is a structure powered by a supermassive black hole. The radiant energy of the quasars are very enormous. The most powerful quasars have thousands of times greater than the galaxies such as a Milky Way galaxy. More than million quasars have been found. with the nearest knowing about 600 million light years away from the Earth. Next, about galaxies. A galaxy is a huge collection of stars, gas, dust, and their solar system. Galaxy is held together by its own gravity. There are many galaxies beside ours, though. There are so many we cannot count them at all. Once an experiment were made a small patch of space for they observed for 12 days and found 10,000 galaxies of all size, shape, and color. Our galaxy name is the Milky Way galaxy. Galaxies or subgroupings. Galaxies are in various shapes, like spiral galaxy, elliptical galaxies. There are some irregular, that shapeless galaxy. Our Milky Way galaxy is a spiral galaxy. Next, about planets. So, what objects are called as the planets? The most recent definition for a planet was adopted by the International Astronomical Union in 2006. It says a planet must do three things. It must orbit a star. You know, our Earth orbits a star. Second, it must be big enough to have enough gravity to force it into a spherical shape. That is, it should have great gravity so that it should convert into a spherical shape. Our Earth does it. It must be big enough that its gravity cleared away any other objects of similar size near its orbit around the sun. As in one orbit, one planet can rotate. In presence of other planet, they both may collapse, so it results in a very danger. So it should have enough gravity that it should move a similar size of any other object near its orbit. So the planets in our solar system, that is the 8 planets, does it, so it's called as the planets. So to be a planet, there are some needs. Our solar system contains Sun at the center, next Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The Pluto is regarded as the draft planet because it does not satisfy the rules of a planet. Let's know about next exoplanets. All the galaxies have different types of solar systems. You know, our sun orbiting planets are called planets. Similarly, any other planets orbiting other stars are called as the exoplanets. Now, many researchers search for exoplanets, and these planets affect on other stars they orbit. Next, about dwarf planet. Dwarf planet are heavenly bodies that are too small to be considered as a planet, but too large to fall under smaller categories. The International Astronomical Union defines a planet as something that obeys the following criteria. It should be in orbit around the sun, has enough gravity to pull its own mass into a round shape. He has cleared at orbits of smaller objects. Okay. This is a category where the Pluto falls into a dwarf planet. Planets and dwarf planets differ at the last point. A planet gravity would either attract or push away smaller bodies but obstructs its gravity. But the gravity of the dwarf planet is not sufficient to make this happen. Currently, 5 dwarf planets, namely Ceres, Pluto, Eris, Hermes, and Makemake, have been discovered. Scientists pursue that there may be more than hundreds of dwarf planets awaiting discovery. Next, about satellites. Satellite is a moon, planet, or mission that orbits a star or a planet. For example, our Earth is a satellite because it orbits the sun. Likewise, the moon is a satellite because it orbits the Earth. Usually, the word satellite refers to a mission that is launched into the space and moves around the Earth or in another body in space. Earth and the moon are examples of natural satellites. Thousands of artificial or man-made satellites orbit Earth. Some take pictures of the planet that help meteorologists predict weather and track hurricanes. Some take pictures of other planets, the suns, the black hole, dark matter, and faraway galaxies. These pictures help scientists better understand the solar system and universe. Still, other satellites are used mainly for communication, such as TV signals and cell phones around the world. More than a group of 20 satellites make up the global positioning system that is called as a GPS. If you have a GPS receiver, these satellites can help figure out your exact location. Not one satellite is used. Totally 20 satellites make up the global positioning system. Moon. Moon, also known as the natural satellite, or it orbits our Earth. Earth has one moon, and there are more than 200 moons in our solar system. Most of the major planets, except Mercury and the Venus, have moons. Pluto and other dwarf planets, as well as many asteroids, also have small moons. Saturn and the Jupiter have most moons. Moons come in many shapes, size, and types. List of number of moons present in the solar system. Earth has one moon, Mars has two moons, Jupiter has 67, Saturn 62, Uranus 27, Neptune 14, Pluto 5 moons, Eris 1 moon, Hawaii and 2 moons. You know, our Earth's moon is the only moon called as moon. Other moons have different names. Next, about asteroids. Asteroids, sometimes called as the minor planet or rocky airless remnants left over nearly early formation of the solar system about 4.6 billion years ago. The currently known number of asteroids is 11,13,527. Most of the ancient space rubble can be found orbiting the Sun between the Mars and the Jupiter within the main asteroid belt. The asteroid range in size from Vesta, that is the largest, at about 329 miles, that is 530 kilometers in diameter, to the bodies that are less than 300 feet, that is the 10 meters across. The total mass of the asteroids combined is less than that of the Earth's moon. Comets. Comets are frozen leftovers from the formation of the solar system, composed of dust, rock, and ices. They range from few millimeters to tens of miles wide, but they have orbit closer to the sun. They heat up and spew gases, dust into the glowing head. They can be larger than a planet. These materials forms the tail. It stretches millions of miles. Due to the heat of the sun, these comets, with full of ice and other particles, they start melting. Those melting results in the tail. Comets are cosmic snowballs of frozen gases, rocks, and dust that orbit the sun. There are likely billions of comets orbiting our sun in the Kuiper belt and even more distant Oort cloud. The currently number of known comets is 3,743. Halley's Comet. Halley's Comet, or Comet Halley, is a short period comet visible from Earth every 75 years to 76 years. Halley is the only known short period comet that regularly visible to the naked eye from Earth, and thus the only naked eye comet that can appear twice in a human's lifetime. Halley last approached in the inner parts of the solar system in 1986 and will next appear in 2061. Don't forget to see Halleck's comment in 2061. Voids. Cosmic voids are large spaces between the filaments. That is, this is the places in space where no objects or no matter is present. These spaces are called as the voids. Thank you. I think this session was useful. Thank you so much.
Thank you. All the very best for your future, Heather.
Thank you, ma'am.